All right, well, we've gone ahead and we've got we've had the analyzer turned on now for an hour, and it's warmed up. The LVDT is all warmed up. We've checked the bubble level up top, and it's right in the middle of the dot, which is where we want it to be and where we want you to align it. And just for our side, to make sure that you're going to be getting what we expect you to on your side, what we've done is we've called up a friction test here, and we're shooting for 150 to 300, which basically should be 1.5 millinewtons to 3 millinewtons. And we've run that test. We've actually run it 3 times, and if you can see here, zooming in, it's coming out with 169 3 times in a row, which is very good. We like it on the low end because it gives you a long way to go over the years, so that if you pick up any contamination from your laboratory environment, it's going to give you a pretty good while before you start going out of that range and start having any trouble. So what I'm going to do is I'm going to close this out, and then we're going to go to the calibration screen, and we're going to start the DMA cal. Now when we start the DMA cal, it's a 30-minute calibration. So we're going to stop the video, and then we will restart when it's done to finish the calibration. So I'm going to close out this, and I'm going to go to the top file menu bar while we're under method, and I'm going to view calibrate, and here is the we have a calibration that we have in that was done the other day. You can see the 828/16 that we did. Anytime you start a calibration, what you want to do is you want to restore all your defaults. So we want to restore all. Top file menu bar now is changed, so you restore all. And then we're going to save and apply. You know, you're only seeing DMA cals, and you see we've done a number of those for other instruments on this computer. I like to put the date in here. You're just seeing DMA ones, but it's going to show you the date. So what is today? The 8th, Andrew, or
9th?
9th. So we're going to go 09/09/2016. Never save it as a default. So now we're back. We've named the file. Everything's back to where it started, and we're going to do our begin calibration. So begin cal. Make sure your samples on the probes on the platform. Okay. Furnace must be up. I know I always forget that. Okay. Okay. There you go. And the screen says 25 minutes. Pretty much it. We'll be back. Okay. DMA cal's done. We're going straight over to do the height calibration. Now, you know, we're looking at sinusoidal force. We're looking at response, how high up it comes, how much longer it takes, amplitude, phase line. If we're going to look at amplitude, we really need to know that we have a high level of confidence we have that the instrument is reading the height that's there. So we have a slug here, a quartz slug. We've measured it 12 millimeters. I mean, not 12. I'm sorry, 10 millimeters. And we're going to look at 0. We're going to put this in there. We're going to tell it to read it. This probe's been down a while, so it's not going to recycle. I believe at PerkinElmer they used to say to let you leave it down for 3 minutes. This has probably been down much longer than that. But when we come back and do the top, we'll go ahead and let it leave longer. To start this calibration, we're going to say begin cal. It's going to say that. Make sure there's no sample there. We're going to say OK, and now if you can't see this, it's reading minus 0.454 millimeters. Now we had this up a few minutes ago. It was reading the same thing. So we're not expecting this to recycle. Normally I would leave this on long enough to get a jump where it's taking a second reading. That first reading, when you come down, it's real easy to get for the system to to read before it's really stable. So we're going to say OK here. And now it's going to come back. I don't know if you can see the screen, but it's going to say raise the probe, and we're going to put the sample in. So we're going to raise the probe. And, you know, we really like to do this with something over here, especially these old guys like me. I really needed tweezers to put in here. I want you to look at this slug in here. Some of these 3-point bendings will have a little post in there, and you might, if you get one of those that's not quite smooth, it can get a little rocky. So, yeah, you can always put a parallel plate, one in there that is absolutely going to be smooth. This one here is smooth, so we're fine with it. But I have seen, you know, several of them that for one reason or another were not as stable as they should be. So if you see one's a little rocky, it's a good idea to change it. Probe's up, probe down, and we're going to say OK. And it immediately came back to 10.376. So let's let that sit there for just a minute and see what it comes back to. Okay, it came back, you know, probably within 30 seconds. We let it sit for a little bit longer to make sure it wasn't updating. When it came back at 9.997, and now it's 9.996. So we're pretty good there. That's what we would expect after the electronic calibration we've done. So we're gonna say OK. Save and apply came back. The time up here is when we saved it last time. It's not right this minute. So we're going to save and apply. We're going back here over the same calibration file we've been using. And by the way, one thing, since the file's not up right now, one thing I do a lot is I'll go in there and I'll create an archive folder and dump all the old ones in there, but we're not going to do that right this minute. So we have a measured thing here. We are we're going to go on to our force. Let's go ahead and take this out of here. So we're going to go up. Oh, didn't mean to touch that, y'all. Put that down. We're going down. Now, if we're going to put a sinusoidal force on here, we probably, it's going to be a pretty good idea if we know how much force we're going to be putting on here. So, we have a platform, we have a 50-gram weight. We're going to say begin cal. It's going to tell us to put the platform up here, which is going to sit on top of the core rod. We're going to say OK. Now it's going to say put the 50-gram weight on top. DMA calibration has been completed successfully. So we're going to say OK. We're going to save and apply. Go over that same file again. And we're done. Now when we do we're done with the force cal. What's going to happen when we do the performance valve verification, we will actually go back and we'll find out where true zero is on here, and and then we'll make sure we have a spread that's equal to the weight of the weight. Okay, so now we're going to go to eigendeformation calibration. This is a great analyzer. It is not a perfect mechanical device. I don't know if there is there is not a perfect mechanical device. And so the purpose of the eigendeformation is to put a consistent, forces at zero. We put them on top of a steel slug that's not going to move. It's going to look at the changes that it finds, any changes in the flexure between the motor itself, the core rod, the probe, the sample tube, anything, and it's going to remember that in the software calibration. So to start that with it at 0, we're going to say begin cal, click OK, calibration in progress. It starts out at 100 millinewtons. It's going to be there for 25 seconds. And we're going to be patient. We're going to sit back for it to finish that. And then I'll go to another portion. I'll tell you as it goes through that. Okay, now it's gone through that. It's at 2100 millinewtons, and there for 25 seconds. Okay, next raise the platform, put the slug in. So we're going to do that. Then click OK. And we're back to the 100 millinewtons, 25 seconds ago. We'll be patient again. It'll pop back up. So this, when this is done, and go up to 2100, I believe, again. Okay, raise the probe. I'm going to raise it. Take it out, put her back down, click OK, and what do we do again? Calibration not applied, save and apply, and we're done with that. Now, at this moment in time, we can go in and do the regular. We could go through and actually do some of the regular calibration steps, performance verifications. What we can't do is that we haven't done the temperature calibration yet. We haven't done the furnace calibration. Now the temperature calibration, we have done it with this analyzer previously. We're not going to do that actually on the video. We're going to show you what we got, and we would put an indium in here. There are methods in here for DMA7, and we would run an indium, then we'd run a zinc, or we could run lead or whatever else we wanted to run, and then we would save and apply like before, and then we would go over here to the furnace calibration. And furnace calibration takes about 2 hours. You put the two temperature calibrations, in there first. They take a little while. You're going to want to do those with whatever sort of coolant that you have on this analyzer. You notice right now we do not have a coolant. However, when we worked on this analyzer, we had a recirculator there with what they call a turbulent chamber put on this. So there is a turbulent chamber accessory that comes onto this analyzer that you can run a liquid to. There also is an intercooler 1, intercooler 2. Those are small mechanical chillers that will allow you to go to minus 35 degrees C and minus 65 degrees C. And there also is and I don't think we have one in here right now, a liquid nitrogen dewar that goes on here. And when you do the temperature in the furnace cal, when you have that dewar, you can do what we do in the shop, where that is, we just simply use a coil of copper and put it in there and run a liquid through it. But you also can take out the dewar liner. You can put a block of ice in there and then put it back in and run it. You'll need a fresh block of ice for the furnace calibration. It's going to go from 50 to 250. You do not need to go to change that to your range because it's extremely linear. I have done them 50 to 250 and immerse the thing in liquid nitrogen, and it'd be dead on afterwards. So if you are, depending upon how you're trying to calibrate these things, if you have any sort of trouble, there is feel free to call. I mean, phone calls are free. We're in the office. We're happy to help you out. As far as the installation of any of those accessories, you can go into the Pyrus software and go to the programs Pyrus, and there'll be an installation guide. There also is up top in Pyrus, there's a help file. Quick Help is a terrific tutorial. It also has contents where you can go in and find installation information there too. So right now, we're done with this part. When we come back, we're not going to go through that long temperature calibration for you. When we come back to this, we're going to go ahead and do a performance verification.